Okay, so we are in week 4 of MAT 205 at Wilmington University. We're going to start off by exploring the differences between independent and dependent events. So here's the definitions. To be independent, two events A and B are independent if the fact that A occurs has no effect on the probability of B occurring. That would make them independent events. Now, to become dependent, two events A and B are dependent or depending on each other if the outcome of A has some effect on the probability of B occurring. Okay, let's dive deeper. So let's dive deeper into independent events. So we know that two events A and B are independent if the fact that A occurs has no effect on the probability of B occurring. So here's another way to kind of think about that. An independent event is an event in which the outcome is not affected by another event. Independent events do not affect one another, and they do not increase or decrease the probability of another event happening. Consider choosing two objects randomly, one after the other, from a group of objects. Let's say you replace the first object before you make your second choice. Then the two choices are independent. So for example, let's say you had 4 marbles, a purple, a red, a green, and a blue. Okay, so you have 4 marbles, they're in a bag, and you decide to pull out a marble. So the probability, let's call this event A. Event A. The probability of getting, let's just say a red marble. Okay, so we know that if we had these 4 marbles in a bag and you were to, stick your hand in the bag without looking in, the event A could be the probability of getting a red marble. We know that's 1 out of 4. Okay, then you can throw your red marble back in. So you think about pulling the red marble out. It's a 1 in 4 chance of getting it. Then put the red marble back in. And now let's call event B the probability of getting a purple. Okay, so now the red marble's back in, you shake up the bag, you stick your hand back in there. It's the same probability of pulling a purple. It's still 1/4. So these events are independent of each other. Doesn't matter if you pulled a red on the first time, as long as you throw it back in there, still a 1/4 chance of getting a red. And if all the marbles are still in there and you come back in and stick your hand in the bag again, let's say you get a purple, there's a 1 in 4 chance of getting a purple. Getting that purple is independent from getting that red marble, as long as you replace those marbles after you take them out. So going further with independent events, consider choosing 2 objects randomly, one after the other from a group of objects. Let's say you replace the first object before making your second choice. So that's very much the scenario I was just talking about earlier. Then the 2 choices are independent. Here's some examples. Let's say you have a deck of cards and you randomly grab one and you pull out an ace. And you put it back in and then you draw out again and you get a spade. So getting the ace is independent and has no effect on whether or not you're going to stick your hand back in and grab out another card and get a spade, because you put the card back in. Didn't change the next event, didn't have any impact on it. Or how about you have a die? So let's say you got a little die and you roll it and you get a 4. All right, well then you're going to pick up the die and roll it again and you're going to get a 2. Okay, so getting the 4 and getting the 2 have no effect on one another. Every time you pick up that die and roll again, there's still a 1 in 6 chance of getting a 4, and there's still a 1 in 6 chance of getting a 2. How about, this would be fun, winning the lottery today and then winning it again tomorrow? So these are all independent of each other. If you win the lottery today and they start the lottery all over again and you win it again tomorrow, those are independent events to each other. It doesn't matter if you won it today, you have a fresh chance and the same equal chance of winning it again tomorrow. Okay, let's talk about dependent events. 2 events A and B are dependent on each other if the outcome of the event A has some sort of effect on the probability of event B happening. Another way to think about it is a dependent event is affected by the outcome of a second event. Dependent events influence the probability of other events or their probability of occurring. It's affected by other events. So here's a concrete example. Well, I'll give you one, but here's the definition. Consider choosing two objects randomly, one after the other from a group of objects. You pull out an object and throw it away. So you did not replace that object. That's going to shake things up. That's going to change things. When you go to select the second object, the probability has now changed and the outcome is affected because you did not replace the first object. Now those two events become dependent events. So let's say you have yellow, blue, green, purple, and red. And let's just say these are marbles, okay, in a bag. We'll stick with the marble box. Okay, so the probability, let's just call this event A, is the probability of getting a yellow. Getting yellow. Okay, so event A, we know that if you had all these in a bag and you shook them up and stuck your hand in there, and you have 1, 2, 3, 4, 5 marbles, it would be 1 out of 5 chance, that probability of getting a yellow. But let's say event B happens next. And after you've taken out that yellow, let's say you get it, you take it away. Aha. Well, now the probability for event B of maybe getting, let's just say getting a red, is going to be affected because there's 1 out of 4 chances of getting a red. See how those probabilities are now different? So that's because they are dependent on each other. So this getting this red is dependent upon whether you put that yellow back in the bag. So hopefully that's making some sense. Let's do some actual examples. Here's just some simple examples of dependent events. Pulling an ace out of the deck of cards without replacement and drawing again and getting another ace. All right, so if you pull an ace out of a deck of cards, then you take that card and you just say you throw it away, and then you go to draw another card and you get another ace. Well, the denominator is going to change, right? The first time there's 52 cards in the deck, and the second time there'd only be 51 cards in the deck. So it's going to change. That's why they're dependent. Or here's a little fake little sack, pulling a red ball out of this bag without replacing it, then pulling again and getting a blue ball. So let's see here, pulling a red, that would be 1, 2, 3 opportunities out of 1, 2, 3, 4, 5, 6, 7. Okay. Then if you're going to pull a blue out on the second event, well, let's say you got a red, that's going to leave that out of there. Okay. Now, well, let's just say pulling a red again. Let's just keep it red. Well, you're only going to have 2 out of 1, 2, 3, 4, 5, 6. See how the probabilities are changed? So they depend on one another. Okay, so here's some examples. There's 3 different examples. We'll call this A, B, and C. All right, let's start with puppies. A litter of puppies consists of black and tan puppies. A puppy is randomly selected and removed from the litter. Then, I'm going to underline that, remove from the litter. In fact, I might even highlight that because that's really important. Okay, we have to determine in these scenarios if they're independent or if they are dependent scenarios. Okay. All right, so back to the puppies. The puppy is randomly selected and removed. Then another random selection is made from the remaining puppies. So let event A be getting a black puppy. So event A is the probability of getting a black puppy. And event B is the probability of getting a tan puppy. Okay, now they don't tell us how many puppies. We're not actually figuring out the probability, but we are asked to determine whether this is going to be independent or dependent. So think about this for a minute. Think about what your answer might be. Pause the video if you need to, and then come back. So hopefully you thought about dependent. And the reason that these are dependent is because the first puppy was removed or is removed, it changes the next probability. Okay, so that makes that scenario dependent. How about B? At the beginning of 2 football games, a coin is tossed and the winner of the coin toss is determined. Event A is the first game. The home team wins the coin toss. Event B is the visiting team wins the coin toss. All right, so we have two events. Let's write those down. So event A is the home team wins the coin toss, and event B is the visiting team wins the coin toss. So what do you think? Do you think this is independent or dependent of each other? Okay, so hopefully you're thinking these are independent. And the reason is the occurrence of event A, the home team winning, doesn't affect when they pick up the coin and flip it again, doesn't affect whether B wins or loses. So I'm going to write that out. So they are independent. The occurrence of event A, that coin toss, doesn't affect the next coin toss. It doesn't affect event B. Okay, our last scenario. A box contains pens. Some pens have ink, some do not. A teacher randomly selects a pen and sets it aside. Okay, so there's a removal. Then another random selection is made from the remaining pens. Event A is the first selection is a pen with ink. Event B is the second selection is a pen with no ink. Think about if these are dependent or independent events. Okay, so event A was selecting a pen with ink. Event B was selecting a pen with no ink. Keep in mind the first pen selected is not replaced. It doesn't go back into that box. So that makes this dependent. Because the pen was removed in event A, it's going to absolutely affect the probability of when they go to pull out event B. In fact, the denominator is going to change because now there's less pens in the box. All right, so you might be thinking, Parcell, enough already. We got this. But of course, no. I've got to give you more practice. So here's 3 more scenarios. So I want you to pause this video. Maybe take a picture of these scenarios or keep this paused. And I want you to think through what your answer would be as far as independent or dependent with each of these 3 scenarios. Then come back and see me. So for scenario A, if you pick dependent, you would be right. Whether event A occurs most definitely affects the probability of event B. So for example, if event A is the older child has brown eyes and event B is both children have brown eyes, what if the older child came out and had blue eyes? Then that completely affects the probability of both children having brown eyes, because that could never happen if the older child came out with blue eyes or green eyes. So they are dependent. This first event here, whether this child has brown eyes or not, is going to definitely affect event B, that both children have brown eyes. So if you got that one right, give yourself a pat on the back. Okay, a hat contains a slip of paper with the names of kids in a class. A name is randomly selected and returned to the hat. Return to the hat. That's going to help us. Then another random selection is made. Event A is the first selection as a boy. Event B is the second selection as a girl. Well, these are independent. The name was selected out in event A, but then replaced and returned to the hat. So you're going to have the same number of slips back in the hat, and you could very possibly go ahead and get a girl for your second choice out of the hat. So whatever happens in event A had no influence over event B because we returned the name back into the hat. Okay, a number cube with sides labeled 1 through 6 is rolled twice. Event A is the first number roll is a 3, right? So we know that's a 1 out of 6 chance. Event B is the second roll is a 4. We know that's a 1 out of 6 chance, okay? So what do we think about this? Do we think these are dependent or independent? So hopefully you're thinking these are independent, okay? The occurrence of event A, I don't think I'm spelling occurrence right, but it's early in the morning, does not affect, the probability of event B. Because every time you roll a die, it resets, it starts all over. Okay, so they don't depend on each other. There's no influence. Whether you got a 3 the first roll doesn't affect at all if you're going to get a 4. Okay, so they don't have any influence on each other. Okay, so that is it for scenarios of trying to determine independence versus dependent events.